Hello and welcome to part 4 of our trigonometry final exam review. In this video, we're going to cover the last 10 questions of the practice final exam. Let's get started. 31, write the complex number in polar form. Express the argument in degrees. Round to the nearest tenth if necessary. So what we have here is we have a complex number in rectangular form. We can see the value of A is negative 15, and the value of B is negative 20, and we're going to need to find R and theta. So we have formulas to calculate R. That's the square root of A squared plus B squared, and theta would be the inverse tangent of B over A. So for the radius, that's going to be the square root of negative 15 squared plus negative 20 squared. And the easiest way to do that is with the calculator. Square root of negative numbers need to go in parentheses. Negative 15 squared plus negative 20 squared. And that works out to be, oh, that's a nice number. Yay, 25. So our radius is going to be 25. Our angle is going to be the inverse tangent of negative over a negative makes a positive. So that's going to be 20 over 15, which will reduce. You don't have to reduce it, but I'm going to reduce it. That's going to reduce to 4/3. And then since we need that answer in degrees, we're going to put our calculator in degree mode. And we're going to do the inverse tangent of 4/3. 4 over 3. And that's going to give us an angle of 53 to the nearest tenth, 53.1 degrees. 53.1 degrees. Now, when you're finding the angle theta, if your A is negative, you're going to have to add 180 to theta to get the angle to be in the right quadrant. Because if you think about it, if I plot this rectangular complex number, that would go back and down, which would put us in quadrant 3. And 53.1 is a quadrant 1 angle. So you can see that those are going to be 180 degrees out of phase, which is why we have to add 180 to theta. So here we go, adding 180. And you know what? I just don't trust myself that much. Let's just do it with the calculator. 233.1 degrees. 233.1 degrees is the actual angle theta. Now, this is not done. Remember, we're doing complex numbers. The formula for a complex number in polar form is R cosine theta plus I sine theta. And to finish it off, we will need to express this complex number in polar form. You can't just stop with R and theta. You do need to express it in polar form. So that final answer is going to be 25 cosine of 233.1 degrees plus I sine 233.1 degrees. That is the complex number in polar form. Next problem, find the product of the complex numbers. Leave your answer in polar form. And it's a good thing that these are already stacked. Remember when I taught this, I said product means stack them. And the reason you want them stacked, one on top of the other, is it lines up the pieces that go together. So to find the product of two complex numbers in polar form, you need to multiply the radii. 3 times 8 is 24. Cosine of, and the angles need to get added. And the easiest way to add those angles is with the calculator. Now you can either put the pi or you can just put 1/6. I'm just going to do 1/6 plus 1/2, and then I'll add the pi's back in when I'm done. So that's going to be 2 pi over 3 added. 2 pi over 3 is my angle plus I sine of the same angle. And that is done. You can see there's just not a whole lot of work to show there. That is done. Next problem, find the indicated power of the complex number. We're going to be using the Morse Theorem, which says that you take the radius, which in this case is square root of 3, that needs to be raised to the power, and the angles get multiplied. And then you need to simplify that. Notice it does say to write your answer in rectangular form. So as soon as we get this simplified, we will need to express it in rectangular form. Here we go. Square root of 3 to the 4th, that's basically going to be 9. And if you're not sure how to get that, again, you can use the calculator. Super easy. Just do square root of 3 to the 4th. And then for your multiplication here, again, if you need some help, you can use the calculator. 5, and if you want to put the pi in, you can. The Casio makes it easy. And that's going to be 10/3 pi, or 10 pi over 3. Cosine of 10 pi over 3 plus I sine of the same, 10 pi over 3. Now this would be the correct answer if they wanted it in polar form, but they asked for rectangular form. And to get there, we're going to need to do the distributive property. So using the calculator, switch to radian mode because we have radian angles. And we're going to do 9 cosine of 10 pi over 3. And that's going to give me the exact value of -9/2. And then we're simply going to go back to the calculator, back, and delete the cosine and instead do sine. That'll be the second part of the problem where we multiply 9 times sine of 10 pi over 3. And that works out to be -9 square root of 3 over 2. And that is the exact value. -9 square root of 3 over 2. Please don't forget this is a complex number. You do need to put that I there. And that is the final answer in rectangular form. And it is the exact value. Next, vectors. Initial point P and terminal point Q. We need to write the vector in standard form. And so this formula, which I referred to as the 2-point formula when I taught the lesson, this is x2 minus x1. That would be the I component of the vector. And then y2 minus y1. That would be the j component of the vector. And so we just need to plug and play. Now keep in mind the initial point is going to be your x1, y1, and your terminal point is going to be your x2, y2. So we're going to have x2 minus x1 And that negative 5 needs to go in parentheses. y2 minus y1. And simplify. Here we have two negatives make a positive. Negative 3 plus 5 is 2i. 5 minus 2 is positive 3j. And there is the answer. That is the vector in standard form. Next, 35. It wants us to find 3v minus 4w. This is a plug-and-play problem where we're going to replace v with what it's equal to, minus 4, and then w gets replaced with what it's equal to. And the next step is distribute and combine like terms. So we're going to distribute the 3 and the negative 4. That's going to give us 9i minus 15j plus 28i minus 16j, and then CLT, combine like terms. That's going to give us 37i. Negative 15 and negative 16 is negative 31j. And that is done. Next problem. Write the vector in the form of AI plus BJ. Again, that is standard form. And this is going to be using the M and D formula, the magnitude and direction formula. So this vector is going to be the magnitude times cosine of theta I plus sine of theta j. That is the magnitude and direction formula. And then we will need to take the 15 and distribute and calculate the I and j components. And again, these are degrees, so we're going to need to switch to degree mode. And we're going to look at 15 cosine of 30. Again, if you're not allowed to use the calculator to calculate cosine of 30, you can go to the unit circle and find the x coordinate at 30 degrees and the y coordinate at 30 degrees. So it's pretty easy to do manually as well with the unit circle. But with the calculator, we get 15 square root of 3 over 2. That is the I component of the vector. And my guess is 15 halves for the j component. And we will verify that electronically, doing sine instead of cosine. There we go, 15 halves positive. And that answers the question. That is the vector in standard form. Next, find the dot product. Remember, product means stack them. So we're going to write W underneath V. We're going to stack them. And V dot W, the dot product, that says to multiply the A's together. 7 times 9 is 63. Multiply the B's together. Negative 4 times 1 is negative 4. And then you're going to take those two values and add, or in this case, subtract. And that's going to give us a dot product of 59. And that's done. I mean, that's all there is to the dot product. Pretty easy. Next, 38, find the angle between V and W. And I'm going to go ahead and give that formula because it's kind of a complicated formula for finding the angle between two vectors. That is the inverse cosine of the dot product divided by the magnitudes multiplied. So we're going to have to find the dot product of V and W and the magnitude of both V and W before we can actually find the angle. All right, so here we go. We've got the dot product, negative 5i plus 7j, negative 6i minus 4j. Remember, product means stack them. And so v dot w is going to be 30 minus 28, which is positive 2. There's the dot product. And then the magnitude of v and w. So the magnitude formula is the square root of a squared plus b squared. And I'm going to use my handy dandy calculator for that. Although it's not that bad by hand, but I hate to make mental mistakes. Negative 5 squared plus 7 squared. And that is simplest radical form, square root of 74. Magnitude of W is going to be the square root of A squared plus B squared. And again, using my calculator for that, square root of negative 6 squared plus negative 4 squared, 2 square root of 13, simplest radical form. Now that I've got the three key components, I can plug and play. And my angle is going to be the inverse cosine of the dot product divided by the magnitudes multiplied. And then I can feed all of that into the calculator all at one time. And I do want my angle to be in degrees rounded to 1 decimal place. So in degree mode, inverse cosine of 2 over square root of 74, don't forget to move out from under the radical, times 2 square root of 13. And to the nearest tenth, 1 decimal place is going to be 88.2 degrees. And just to give you, again, the quick little way you can check and see if you're close, I'm going to sketch the graph of each vector and see if it appears to be close to 90. 88.2 is pretty close to 90 degrees. All right, so vector V is negative 5 up 7. And so that's going to put that vector something like that. There's vector V. Vector W is negative 6, negative 4, which is going to be something like that. And that angle does appear to be acute, but it's pretty close to 90, so that makes me feel pretty good about this answer here. Again, it doesn't take long to sketch those vectors and see if it looks close to what you got. Next, 39, find the exact value. They want the magnitude, and this is a three-dimensional vector. So the magnitude of a three-dimensional vector, that is going to be a squared plus b squared plus c squared. The square root of a squared plus b squared plus c squared. And then from there, we can use the calculator. So again, this is pretty straightforward, pretty easy problem here. square root of 70, and that will be simplest radical form. And that's done. And the last problem on the practice final exam, they want us to find the cross product. And since it does say show your work, I'm going to use determinants. I, J, and K. So we're going to start with a 3x3 determinant where the first row is I, J, K. The middle row is the first vector mentioned, which is W, 6, 6, -1. Those are the coefficients of I, J, and K. And then we need the coefficients of vector V, 4, -2, and 1. So there's our 3x3 determinant. And then the technique that I use requires that you copy and paste the first two columns to the outside. So if you see what I did there, I took the first two columns and simply copied and pasted those to the outside. And then we're going to take a different color and we're going to multiply down. We're going down on the diagonal. 1 times 6 times I gives me 6I. 4 times -1 times j, that is a -4j. And then on the next diagonal, -2 times 6, that's -12k. And then I'm going to change direction. And this time we're going to multiply up on the diagonal. And what do you need to remember? When you change direction, you need to change the sign. So 4 times 6 is 24. Change the sign. That'll be -24k. Next diagonal, negative times a negative makes a positive. Turn it back into -2i. And last, 6 times 1 is 6. Change the sign. -6j. And then the last thing that you need to do is combine like terms. I first. I've got -2i plus 6i. 6 minus 2, that is 4i. And then for the j's, I've got -4j and a -6j makes a -10j. And then last but not least, -24k minus 12k, that is a -36k. And that should be the cross product. And so before I close this out, I do want to remind you that the Casio ClassWiz has the ability to check this fairly easily. So let's go to the menu, down to the vector app, and we're going to define vector A as a three-dimensional vector, and we're going to call this vector W since he's first. 6, 6, -1. So we simply input the coefficients of I, J, and K going down. That's vector W. And then I'm going to hit clear. I'm going to go to option, and I want to define vector B as a three-dimensional vector. And this will be the coefficients for vector V, which are 4, -2, and 1. And again, I'm going to hit clear. And now we want the cross product. So back to option, vector A, cross is the times button, cross product, option vector B. And so this should be W cross V, and it gives the coefficients of I, J, and K going down. So 4I minus 10J minus 36K, and the calculator will verify that for you. And that is it for the review for the final exam for our trigonometry class. If you have any questions or comments, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.